Dear friends, welcome to another video. Today we are going to see how to use this inexpensive 2.8-inch touch display with Arduino. Is this touch display a good option for your Arduino projects? Keep watching in order to find out. Hey guys, I am Nick and welcome to Educate TV, a channel that is all about do-it-yourself electronics projects with Arduino, Raspberry Pi, ESP8266 and other popular boards. Today we are going to take a look at this 2.8-inch touchscreen designed for Arduino. As you can see, I have loaded a demo program that displays a button on the screen. When I press the button with my finger, the program displays a message. As demonstrated, the touchscreen is working fine. Finally, we can start building projects with a touchscreen which are much more interesting and easier to use. I discovered this touchscreen on banggood.com and I decided to buy it in order to try to use it in some of my projects. As you can see, the display is inexpensive. It costs around $11. You can find a link for it in the description of the video below. The display offers a resolution of 320 by 240 pixels and it comes as a shield, which makes the connection with Arduino extremely easy. As you can see, the display uses almost all of the digital and analog pins of the Arduino Uno. When using this shield, we are left with only 2 digital pins and 1 analog pin for our projects. Fortunately, the display works fine with the Arduino Mega as well, so when we need more pins we can use the Arduino Mega instead of the Arduino Uno. Unfortunately, this display does not work with the Arduino Due or the Wemos D1 ESP8266 port. Another advantage of the shield is that it offers a micro SD slot, which is very easy to use. Let's now see the software side of the project. In order to use this display, we need 3 libraries. We need a modified version of the Adafruit TFT LCD library, the familiar Adafruit GFX library, and the touchscreen library. You can find links for all the libraries in the description of the video. After installing all the libraries, we can now load any of the examples of the TFT LCD library. This is the graphics test example. Impressive, isn't it? This is the TFT BMP example. Just place the BMP files that come with the library in an SD card and load the example. Great, isn't it? We can now build some nice project based on this example. Now let's move on to the touchscreen functionality of the display. Load the example program I have developed. You can find it in a link in the description of the video. First of all, we have to calibrate the display. Open the serial monitor and click on the top left corner of the display and write down the X and Y values. Then enter these values at these variables on the code. The X value goes to the TS max X variable and the Y value that we wrote down goes to the TS max Y variable. We follow the same procedure for the other 2 variables. We click on the bottom right corner of the display and we enter the values we get in the TS min X and the TS min Y variables. That's it. Our display is now calibrated for this program and it is ready to use. If we touch the red button, the program will display a message. When we touch the display, the touchscreen library reports back the point that we clicked. We can get the X and Y values of the point, but these values are not in pixels. We have to convert these values into pixel values. This happens here. We use the bump function in order to convert the values we get from the touchscreen library into pixels. Notice these 2 values, 320 and 240. They are the resolution of the screen we use in pixels. Now that we know the X and Y values of the touch point in pixels, it is very easy to make clickable buttons. Let's start from the beginning of the code. At first we clear the screen and we draw a black background. Next we draw a white frame with this command. With the following 4 commands, we print the word hello on the display. We place the cursor at the desired position on the screen, we set the text color to be white, we set the font size and we finally print the hello text. By following the same procedure, we print the red YouTube text as well. The next step is to draw the red button. At first we create a red rectangle. The top left point of this rectangle has an X and Y pixel coordinates 60 and 180. We define that we want to have a width of 200 pixels and a height of 40 pixels. So the bottom right pixel of the rectangle we have a pixel coordinates 260 and 220. Next we draw a white rectangle on top of the red rectangle with this command. This makes the red rectangle to look more like a button. The last step is to draw the subscribe text with these commands. Now, in the loop function, each time the user clicks on the screen, we convert the point coordinates of the touch point into pixels. If that point is inside the red rectangle area, that means that the user has pressed the button. So we disable the button by setting this variable to false, we clear the screen, and we display a message on the screen. From the above example, you can see that building a touch interface with Arduino is relatively easy if you understand these simple concepts. I will prepare another tutorial soon with more buttons and menu pages in order to be more useful. This is just a demonstration of how this touch screen works. As a final thought, I think that this is a great display for our Arduino projects. It is big, it is inexpensive, it has a good library support, it offers a nice resolution, and of course it can be used as a touchscreen. I am going to build a lot of projects using this display since it is so easy to use. What kind of projects do you want me to build with it? Please post your ideas below and I will try to implement them. Thanks! If this is your first time here, I would love to have you subscribed. In this channel, I post videos about do-it-yourself projects every Saturday. I love making things and I believe that anyone can make things. Anyone can become a maker. That's why I created this channel in order to share my knowledge with the community and learn from the community. I hope you will join us. Until next Saturday, watch, learn, build.